This session is going to look at variations in setup for external 4-to-1 systems, and the idea of the session is to address questions that commonly come up on WRT classes. So a 4-to-1 system is popular in the WRT world, so raft guides, recreational kayakers, expedition kayakers, because what we're doing is we're creating a compound system which allows us to have more mechanical advantage without adding an enormous amount of additional equipment. And what we have set up on the table here is 3 variations of a 4-to-1 external piggyback system. So on this side we have the anchor, and on this side we have the load. And what we have as a first variation is a tape running through carabiners, so running over the carabiner here and here in order to generate our mechanical advantage, and then we have no knot in the system here, and this is running over a carabiner, creating friction in order to hopefully prevent the system from spinning around in a circle. What we have here is the same system, but in this iteration we have an 8mm piece of low stretch kern mantle rather than the tubular webbing. And then in the third variation, what we have is pulleys at our change of direction in order to reduce friction, and then at our anchor side we have a knot which is going to prevent the system from spinning through. So the issues that we want to look at is, does the choice of material make a difference to the amount of mechanical advantage we generate, and whether or not the system slips or functions, whether adding pulleys in order to generate our mechanical advantage gives us a significant benefit, and whether or not we need to add a knot on the anchor side of our system. We performed some basic field tests. So in our field tests we gained an indication of the rough efficiency of a tape running over a carabiner, rope running over a carabiner, and rope running through a pulley. The rope running through a pulley, as expected, gave us the most efficiency, and through multiple tests it proved to be about 90% efficient. Obviously there's lots of variables that would affect the efficiency, so there's potential that it could be slightly more efficient than that or slightly less, but an indication of 90% gives us a good idea of what we're getting in terms of mechanical advantage. In terms of the tape running over a carabiner and the rope running over a carabiner, these actually proved to be very similar. There was very little difference within the testing, and both tape over carabiner and rope over carabiner showed to be about 50% efficient. So here we have our first system set up. So we have this end, our load side, representing a short line that hasn't made it all the way into the bank, so we don't have enough rope to create an internal mechanical advantage system. So fairly typical setup in a WRT context. And then on the left hand side of your view, this is towards our anchor, and we're using tubular webbing to create mechanical advantage with no knot on the anchor side of the system, and we have a blue tab to indicate any creep within the system. So on a hand over hand pull, what we see is there's actually very little creep in the system. The tackle doesn't spin very much. So what we have here is the second variation, and this time exactly the same system, but instead of the tubular webbing we have 8mm LSK with our blue tab to indicate movement within the system. So although we can see a small amount of movement in the blue tab here, that's mostly due to the stretch in the rope, and there isn't actually that much movement in terms of creep or rolling through the system. So the next variation that I'm going to show is our 8mm LSK running through pulleys in order to generate mechanical advantage, but we still have no knot on the anchor side, and again we have blue tape to indicate any movement within the system. So what we can see here is an enormous amount of movement. So what we're starting to see is when we start to apply efficiency into the system, we actually start to generate some mechanical advantage. We're creating imbalance in the system, and the friction in this carabiner no longer can resist against the spin of the tackle. So if we want to create efficiency in our system, and we actually want to increase our pulling power, then what that tells us is that we do need a knot here. Whereas if we're happy to have a very inefficient system and we're not going to increase our pulling power by very much, then no, we don't need a knot here. But that's because our system isn't actually doing very much for us. So the conclusion is, when we run a tape over a carabiner, we're actually generating a lot of friction. So if we look at this system specifically, at this point in the system, we're relying on the tape running over the carabiner in order to generate mechanical advantage. So what we're hoping for is we put one in, one comes out the other side, and we get two there. As we follow the system through, two goes up, two comes out the other side, and we get 4-to-1 mechanical advantage. In reality though, what we get is, we get one going in, and because of the friction here, we get about half coming out. So that's then only 1.5 going up into the next change direction, which means we've got 0.75 on the other side of that. So for what's in theory a 4-to-1 system, we're getting about 2.25. Another thing that's worth noting on the system is we're relying on the tape passing over the carabiner to generate mechanical advantage here, while also relying on this creating enough friction here to prevent the whole system from spinning through. So the argument is, we can't ask this to do one thing here and do another thing here. So the simplest answer is, if you're not looking to generate very much mechanical advantage in your system, if you're seeking to create an inefficient system, then no, you don't need a knot in the system. However, if you actually want to generate some mechanical advantage in order to make that haul easier, we do need to knot in the system, because the mechanical advantage that runs through the system is going to unbalance this loop, and it's going to spin the loop through. So in our final iteration, what we're looking at is pulleys for our change of direction to create efficiency, and then a knot at the anchor side. And for demonstration purposes, this is a very small throw, so it doesn't allow very much movement in the system. In reality, you'd be looking for double this, but it just helps to illustrate this much more clearly. So now what we're doing is we're generating efficiency in the system. We're actually creating something closer towards our 4-to-1 mechanical advantage, and we've put a knot at our anchor side to prevent the system from just creeping and slipping through and losing even more efficiency in that way. So again, this comes down to the fact that if we actually want pulling power, if we actually want to create a mechanical advantage in order to make our haul easier, then we need to prevent the creep in the system. It's only the inherent inefficiency of using a sling over a Karabiner, the inherent inefficiency of generating mechanical advantage in that way, that allows the system or prevents the system from creeping through and spinning.